I mean, what AI can do today is just staggering, right? It can whip up incredible art, write really complex code, even compose poetry that sounds human. It really feels like we're right on the edge of creating a true artificial general intelligence, or AGI. But dig a little deeper, and you start to see that some fundamental, really crucial pieces of the puzzle are still missing. So, yeah, that's the big question we're tackling here. With all this incredible power, what's actually holding an AI back from truly thinking and understanding the world the way you and I do? And the answer? Well, it pulls back the curtain on some really deep, profound differences between silicon and synapses. And it all starts with how they learn. All right, first up, and this is maybe the biggest piece of the puzzle, it's the very way AI learns. See, it's fundamentally different from how our brains work. For an AI, it's not this continuous flowing process. It's more like taking a single static snapshot of knowledge. And when you put them side by side, the difference is, well, it's night and day. You've got AI over here, which goes through this massive one-time training session on a very carefully prepared data set. The result? A fixed body of knowledge. Then you've got us, humans. We are constantly learning, adapting with every single thing that happens to us, driven by nothing more than our own curiosity. Okay, here's a really simple way to picture this. Think of a current AI model as a book that's already been printed, bound, and shipped. All the words, all the knowledge is fixed on the page. It can't just scribble in the margins or add a whole new chapter after having a conversation with you. It doesn't learn from actually being used. Now, compare that to us. Our brains are basically learning machines that are always on. We're constantly processing information from our senses. Heck, we even learn in our sleep. We build new connections when something surprises us just by watching, by passively soaking in the world around us. Today's AI just doesn't have any of these mechanisms for real, honest-to-goodness lifelong learning. So, because of this whole static learning thing, you start to see these blind spots in how an AI actually processes the world. Let's dive into these cognitive gaps, starting with something that seems really basic but is actually incredibly complex: perception. So, perception. And look, this isn't just about an AI's ability to spot a cat in a photo. It's about grounding knowledge in the physical world. It's about understanding what a cat is because you've interacted with one. You know it's soft, you know it purrs, you know its claws are sharp. You see, without that real-world anchor, all of its knowledge is just floating. It's all abstract, not really connected to anything real. And that's why so many researchers are saying, hey, before we can even dream of getting to higher-level thinking, we've got to solve these fundamental problems of perception first. Okay, next up, memory. Now, you'd think computers would have this one in the bag, right? Perfect memory and all that. But the kind of memory we use every day, that flexible, messy, contextual stuff, yeah, AI has some serious problems there. For starters, it's not great at just pulling up the right piece of info when it needs it, the way we can instantly remember some random relevant fact from years ago. It doesn't have our deep understanding of context. And here's a weird one. It can't forget things on purpose. It treats every piece of data as equally important, unlike our brains, which are constantly sorting and prioritizing what's worth holding on to. You know, this gets to another huge issue: attention. And there's this one line from the research that just nails it. LLMs don't deal with surprise. So what does that really mean? It means when an AI sees something totally new, something that completely breaks the patterns in its training data, it can't just create a new box in its mind for it. It's stuck trying to force this brand new square peg idea into the round holes of what it already knows. And that's a huge barrier to true learning and adaptation. Okay, now we're getting into the really mind-bending stuff. This is the stuff that feels like it's straight out of sci-fi. We're talking about the internal world of an AI, or more accurately, the lack of one. We're talking about goals, self-awareness, motivation, the ghost in the machine. Let's just ask a really simple question here. When you give a prompt to an AI, is it pursuing a goal because it wants to? Or is it just mechanically following a mathematical path that its programming tells it to follow? And again, the difference here is just fundamental. Today's AI is trained with what you could call cold targets. There's no internal fire, no motivation, no desires of its own. It's basically a reproductive system. Not in the biological sense, of course, but in that it just reproduces patterns it's seen before. We humans, on the other hand, we're driven by our own internal needs and goals. We're dynamic, constantly trying to make sense of everything. And this might be the trickiest one of all. Can an AI know what it doesn't know? It's a concept called metacognition. Thinking about your own thinking. And right now, the answer is a pretty clear no. These models just don't have a built-in mirror to reflect on their own knowledge. They don't have a model of cause and effect that would give them an intuition, a gut feeling, about whether their answer makes sense or if it's just a confident-sounding guess. Without that, they can't really guide their own reasoning.
So wow, after hearing all that, you might be thinking, well, AGI is never going to happen. But that's not how researchers see it. For them, listing out all these problems isn't about giving up, it's about drawing the map for what comes next.
And here's what that roadmap to AGI basically looks like. Step 1, we've got to crack continual, lifelong learning. Step 2, we have to ground AI in the real world through perception and interaction. Step 3, we need to figure out how to build systems that have their own intrinsic motivations. And finally, step 4, develop some form of artificial self-reflection or metacognition. So when you boil it all down, the whole game is about this one crucial shift. It's about moving AI from being a static system, a pattern-matching machine, to something totally different, a dynamic system that can actually make sense of the world, all on its own. And that, of course, leaves us with one last massive question to chew on. As we chip away at these huge challenges and try to forge these missing links, are we just building a fancier hammer, a better tool, or in the process of trying to build an artificial mind, are we accidentally discovering the very blueprint of our own?